Hello, hi, and welcome everyone to the September edition of the Micro Frontends Meetup. So today we have, as usual, I would say, so we are quite blessed, two amazing guests that will tell us about their journey into the Micro Frontends world and what cool projects they are doing. But before we can start, the usual stuff, right? A few organizational words. All right, so as you all know, this meetup is streamed online and also recorded. So if you have any questions, and we will bring them up, they are visible on screen. If you don't want that, then please don't use the chat functionality of YouTube, but just mail us the question, write it to us in LinkedIn or whatever, and we will also address the question, of course. The URL for the recording is made available. It's the same URL as the one that is used for the stream. So yeah, you can always access that one. Now, as already mentioned, this is an interactive session and you can ask questions, but please use the chat appropriately, be polite in there, and don't harass anyone. We are quite strict in that regard and will not tolerate any personal attacks or similar things. So please just be professional, as we know you all. So until now, there was no incident and we hope to keep it like that. Besides, of course, our standard code of conduct, we also always want to reach out to you. If you have a story to share, if you want to be on the show, if you want someone else to be on the show and you have a potential candidate, then get in touch with us. And we always like to hear from you, who you want to see, who you want to hear. And then we love to make that happen. So please reach out to us. We're always here for you. And we want to have this community event really embracing everyone and all the opinions that are out there about micro frontends, web development, maybe in general, and other interesting topics. In the last two editions, we announced the State of Micro Frontends survey. It's still out there. Now I promise that we will finish it in August. But two things happened. First of all, we are now, I think, at 1,200 or something votes or participants. And so I like to keep that rolling for a bit, but even more striking, I didn't have the time yet to, let's say, update the website that you can access, let's say, all the charts and these things. But it will come. As you know, the repository for this thing is also open source. Maybe you want to take it over, but I will find the time, I promise, and it will be concluded soon. And we will also see the results not only in writing, but also here in one or two slides, I guess. But yeah, it will come. So sorry for that, but just that you know it isn't lost. And thanks for everyone for participating. Finally, the usual thing, right? We also offer some workshops in that regard. And just check it out if you're interested. There's a variety of topics from very special things like to Pyral or module federation or other things, also very high-level architecture workshops, etc. So if that's interesting, there you go. And with this in mind, I would say let's not lose any more time on the organizational stuff. Let's get that out of the way and let's introduce our guests. And I would like to start with Alex, who works as the director of the software engineering at Adidas. Hi, Alex.
Hi, everyone.
How are you doing?
Doing very well. Good to be here.
Great. Yeah, we are really happy that you made it. And maybe you can pick up the introduction, introduce yourself to the audience and what you brought today, what you want to present later on.
Sure. So I'm a director of software engineering in Adidas. So my main role is to lead, let's say, a platform team for front-end development. So my team is responsible for implementing Micro Frontends architecture across Adidas.com. So the global Adidas e-com solution.
Great. I mean, I think scalability must be really one of the key indicators that the solution is working, right?
Absolutely. This is why I'm here.
Awesome, awesome. Yeah, and I think also everyone in the chat is really eager to hear that story. But you're not alone. We also have a second guest, and let's welcome Matteo also.
Hello, everyone.
Hi.
Thank you so much for the invitation.
Yeah, you're welcome. Really nice to have you here. You're working at Nearform as a software engineer. Can you tell us a little bit more about yourself and maybe your role in the Module Federation community?
Yes, I'm Matteo. I'm 29. I'm from Italy, and I'm a senior software engineer at Nearform. For work, I develop high-performance solution for our customer. And in the Module Federation, I'm actually one of the contributor of 2 plugins that we are going to see today in my presentation.
Nice. Awesome. Cool. Okay, then I would say let's all stay on stage and let's give Alex the screen here to walk us through Micro Frontends at Adidas.
Thank you. So let's start with just a little bit of introduction how I came to this to Adidas and like all the background behind Micro Frontends architecture. So originally I'm from Serbia. I've been in web development for a long time. One of the key reasons why I joined Adidas is because I love all kinds of sports. I've been with Adidas for the last 5 years. I moved to Germany with my family. And if you want to reach out, you can find me on LinkedIn or Twitter with Amirilovic tag. So first, a little bit about the context, like how we ended up here. So even before I joined Adidas, this is like the dinosaur age. The Adidas was actually using a software as a service solution for ecom, and everything was running well for some time. But quickly, as the business was growing really fast, we experienced a lot of problems, not only in the scalability of that solution, but also in the speed that we can actually deliver features to the end users. So then the first initiative for actually starting owning more of the website internally came to life, and we started building a team of internal and external developers that started developing this solution. So of course, the first thing you build a website in Polymer. If any of you know what Polymer is, it's a framework from Google that didn't live very long. Of course, that was a complete disaster. So we started transitioning to React, and we started building the website in React, and that was really a success, where we were able to deliver like a product page to one market. It was Finland, and Finland for us is a market where we deliver features, new features first, and this was really a big success, and then things really picked up very fast from there. So this is where the new solution started being rolled out to more and more. We started onboarding more and more features and starting rolling this out to more and more markets. And so essentially the website was rolled out to more than 40 markets across the globe. And important to say is that we were building a solution both for Adidas brand and also Reebok brand. So Reebok was part of Adidas at the time. And the scale is, let's say, pretty big, right? So we're talking about 100 million unique visitors every month. The revenue, of course, like is triples, even quadruples in the meantime. And we have a lot of front-end developers that are working. So we have like more than 100 people, 20 teams, etc., etc. The development itself is pretty agile. We deploy to production multiple times per week, but I will explain what's the problem with that. And we managed to actually go through the holiday season without any major incidents. So what's the problem? So the problem is that we end up having like a mono repo with more than 80 packages. So like a lot of code, and code mixed from many different domains, which is very hard to actually understand and onboard to. We have a very everything's pretty much slow. So you have npm install, it takes like 20 minutes. You have if you want to run development, it takes more than 10 minutes. Of course, at the time we were using Webpack, so that was really slow. Then the CI pipeline, when you commit and push your code, that takes 60 minutes to complete. We are running a lot of testing, of course, because the revenue is very big. So any mistake costs a lot. So the testing is very important. And of course, on top of the unit tests and let's say integration tests that run in the pipeline, we also have end-to-end regression testing that takes more than 2 hours to do. And it also involves like a completely separate pipeline and a separate QA team that's actually doing this. And on top of that, we also have, since like this regression testing takes a long time, a lot of tests are running there. We have a lot of false positives, which means that the QAs need to manually review the runs, the test runs. And then this manual approval takes easily like most of the day, so like 6 hours to do or something like that. So essentially, what I'm aiming at here is that even though we release to production a couple of times per week, it still requires a lot of insane amount of effort to actually do all of that, and we have a lot of waste of time in the process. And regarding the architecture at the time, it basically looks essentially like this. We have an API service. We have the what we call BFF, but essentially it's just it is responsible for server-side rendering the React page, and we have the front-end code, right? And this API is also connected to many different backend APIs, external or internal, which deliver data for the front end. So just to one note is that this is very early days of React. So we're talking about 6 years ago, and there's no Next.js, like everything's class-based React development. There are no hooks, no state management, nothing of that sort. So we use what exists at that time. So it was like everything was built around Redux. Unfortunately, with Redux, it's hard to decouple things. So things are basically mostly dependent on the global state. So there is no clear separation of things. It's very hard to refactor something and without breaking something else, etc., etc. So things are, let's say, not ideal on that end. Also, there is a lot of things where we have stuff in the repo which is considered to be like configuration, which requires redeployment, right? So if you want to change a feature flag or you want to change some translations, configuration, you need to redeploy the application, right? So then we need additional deployments to actually do this. If you want to roll out something, everybody needs to agree, right? So if one team has a blocker issue, your changes cannot be rolled out, right? And this causes a lot of frictions. Also, we have situations where we roll out and then we figure out that there is a problem. Then when we roll back all the changes that happened in the meantime. So this is also not ideal. Developers, of course, are frustrated because everything is slow, requires a lot of time. So they are mostly just waiting for stuff to be done. And the mono repo complexity just keeps growing. So we're just people are just committing a lot of code, and it's very hard to understand what's happening there and to maintain it, to try to keep it in a let's say predictable manner, how fast is going to be the pipeline and stuff like that. So it just keeps growing. So at this moment, we started investigating different tooling that is specialized for monorepos, like for example NX. And this gave good results. So for our pipeline took something like 60 minutes to complete. So anytime you commit something, you have to wait 60 minutes for the results of the pipeline. And with NX, we managed to cut down this to 45 minutes, right? So, and this is like a percentage-wise, it's a good improvement, but still waiting 45 minutes for something to be done is definitely something you don't want, right? So we understand that we are reaching, let's say, the limits of what we can do in monorepo. And in the end, it's just like when you think about it, monorepo is something which requires a lot of specialized people to maintain, and this is the complexity that we don't want. So then we came up with another initiative to change everything. So this is we came up with an initiative called Agile Experience Layer. So this is around 2 years ago, where these were like our guiding. This is our guiding mission, right? So we want to make it easy and fast to develop new experiences. We still want to keep a good and consistent look and feel across the website, and developer experience should be great, right? So developers shouldn't suffer in the process. Of course, we started investigating the Micro Frontends architecture, and this is what we came up with. So, as I said, our solution was really a monolith, so a single page application, like let's say Next.js, single page application with a lot of different pages. So the first thing what they said, okay, we want to split this website vertically and horizontally. So when we say vertically, we have certain product domains. So upper funnel is one product domain, which consists of all the, let's say, browsing pages that the user visits, right? So like the home page, campaign landing pages, product listing pages, product detail pages. So these are the main pages in the upper funnel. And then you have lower funnel or checkout, which when you want to place an order, when you put stuff in your cart, when you define payment and shipping details. So this is all lower funnel. And then you create an order. And the account area is something where the user manages the profile, the preferences, you do login and register in this account area. So these are the three, let's say, major product areas. And then you have like many, let's say, smaller parts of the website, like blog, like help pages, etc., that are also important, but not our core, not our main product, right? And of course, if you want to cut stuff vertically, you need a way to share certain parts of the website. So in this case, we have like, for example, header, footer, cookie consent, etc., which are all the things which each of these applications actually needs. These things we envision to be built as micro frontends, and which can be injected in any of these pages or applications. So before I start explaining like the flow, how micro frontend actually renders on the website, I just want to call out like a couple of things which we like when we implemented the architecture, what we wanted to let's say avoid or have. So the first thing is that we needed to support server-side rendering, because we're building like a e-com website. Server-side rendering is absolutely a must. But we also wanted to make server-side rendering as an optional feature. So for some things like header and footer, server-side rendering is absolutely needed. But for some things which are, let's say, I don't know, login or user preferences or something like that, these server-side rendering might not be important, or you might not even want to do server-side rendering, right? So server-side rendering is a hard requirement, but it's also something that optionally could be implemented. Then a second thing is that we wanted to build an architecture which is, let's say, framework or tool agnostic, right? So I mean, we don't want to build an architecture around a particular technology that will either slow us down in adopting other nice tooling that is coming out from the community. So we didn't want to hard code our solution for React, or we didn't want to hard code our solution for Webpack or stuff like that. So we wanted to make it very agnostic. And this also means that our micro frontend should we should be able to use it with we should be able to render it with different frameworks. So for example, we are doing even right now, we're doing migration from React 18 to React 17. So it should be possible during this migration to run the website with both React 18 and React 17 side by side, right? So rendering in React 18 and React 17 is different. So we for example, in this case, since how we actually built the architecture, this allows us it allows us to do this. And again, if we needed, for example, to server-side render micro frontend on a WordPress website, we should be able to do that. It's not something which a lot of people have requirements for, but for us, we do have requirements like that. So this probably this is why we ended up having an architecture which is most likely not very common, and it basically, like this diagram shows how it's all connected. So the user lands on the website, the request gets served by our application, and what happens then is that our application right now renders just a React page, and in the page there are some placeholders for the content, for the HTML of the micro frontend to be injected. So the application then does additional calls in parallel to the render endpoint. In this case, you can see it in the diagram on the right side. It does an HTTP call and also it forwards some context parameters like, okay, what is the market that you want HTML for? It also could be like, for example, what kind of device it is, or whatever parameter you want to send, you can send to the micro frontend, and it will reply with some HTML. This HTML gets injected into the page together with resources for the micro frontend. In this case, you see that we have index.js and index.css, and then this whole HTML is shipped to the browser. The browser will load the resources for the micro frontend, and then the React hydration will kick in, and everything gets displayed to the end user. So now let's take a look at like some details, how things are actually, what the developer actually sees. So first of all, like if I'm building a new page and I want to use a header micro frontend, this is the code that I have to write, right? So here you see basically a key component, which is micro frontend client, which has some certain parameters like the ID of the micro frontend, where to load it from, and if SSR is enabled or not. When you also see here on the line 16, there is a GL loader component, which essentially this, let's say, inner part defines, the child components define the experience that the user sees while the micro frontend is loading. So basically, we support both like server-side rendered micro frontend as well as client-side rendered micro frontend. So what does that mean? Well, if the user first lands on the home page, we will server-side render the header. But what if I land on the home page and then I click around the website? We don't do hard refreshes, right? So the user will land on the home page, click on a link, open another page, which is actually client-side rendered. So in that particular case, if you have to load a micro frontend, you need to show some loading experience before the JavaScript and CSS are loaded. and then you can actually render the micro frontend. So this code, like for the developer, looks like regular React. They don't have to think about, okay, how is this loaded or anything like that. That's completely abstracted. How do you create a micro frontend? Well, of course, it requires a lot of, let's say, gluing things around. So we needed a consistent way of doing things. So this is why we created a framework, which we call sole, like a sole of a shoe, right? Of course, everything in Adidas is around shoes. And how does it look like for the developer that tries to create a micro frontend? So the developer starts by like running a tool. In this case, it's like a Soul CLI that, and you specify what you actually want to do. So first thing is, like, of course, you need to create a repository, right? So for us, for example, we use Bitbucket. So we built automation to run a command to create a new repository. So this actually creates a Bitbucket repository where you can start pushing your code. Once you create a repository, you can actually bootstrap your project. So now the developer would run something like, okay, I want to create a Soul application, and the type of application is Micro Frontend SSR. And these are just the parameters for the name and the directory where the code should be generated. So the tool runs npm install for you, and you get a structure like this, right? So you get a folder, and inside of this you have a bunch of different things, like, for example, Sonar configuration, Jenkins file, Docker file, everything you actually need in order to deploy your application to production. And for example, we also abstract other things like I forgot to mention that once you create a repository, you would also get all the Jenkins pipelines, right? So for the CI process generated for you, and the script that we run, we also, as a core team, we developed this Soul pipelines, which, as you can see here, is just calling a functions, importing a library and calling a function Soul CI with some certain configuration parameters, and it will do everything for you. So it will like build a feature branch. It will deploy something in the development cluster for you. It will, you can, with that you can release to staging, to production, etc. Right? So we handle all that for the team. When you're building a micro frontend, we wanted to have an experience like the user shouldn't really care. It's a micro frontend. They should be just doing what they do best, and this is like building React components. So as you can see, so this, what you see on the screen, is basically just a simple micro frontend, right? So there is no magic here. You're just writing a React component, and using just some common libraries from Soul. So in this particular case, you have this host info context hook that you use. This provides information like what is the environment that you're running in, what is the brand, is it like Adidas or Reebok or something else in the future, or is in which locale is the application currently on, right? So Germany or Great Britain or whatever. So yeah, so here you can be as productive as you usually are with the React, and you don't have to think about the infrastructure or the gluing of everything or anything else. Once you're happy with your code, you just push to main, and Soul also provides a command to deploy this to an environment that you want. So you just run Soul deploy, and you choose an environment, and you deploy that to that environment. So okay, so what are the results of actually implementing all of this? So first of all, like we don't have a single repository anymore. We have a repository per domain. So this means that when the user is onboarded, they see the code for their domain, which everybody should be familiar with. So you don't see some code which you don't understand or something like that. So it's much easier to onboard people. The npm install problem that we had, like 20 minutes, it's basically 2 minutes. It's basically nothing right now. So this contributes to developer experience. npm run dev takes just a couple of seconds. One of the main, of course, there is much less code, that's for sure, but also we adopted Vite in the process. So this is, of course, much faster than using Webpack. Then we have a CI pipeline. It took 60 minutes before, now it takes 10 minutes, and this is actually with all the testing included for the micro frontend. So there isn't a separate regression testing pipeline for the micro frontend. There is no manual QA approvals anymore. So everything is now automated, and we basically support continuous deployment of all the changes. And instead of deploying something to production a couple of times per week, now we do multiple deployments per day. So we are able to deliver features to the users much faster. Also in the process, we needed to separate these things like feature flags, translations, and different types of configurations into separate services, so that everything can be orchestrated from one place, and it doesn't actually require any additional deployments. So key learnings for us are actually that, like, so first of all, like, my frontends architecture or building any kind of distributed system adds a lot of complexity. So I would definitely not advise implementing micro frontends architecture unless you absolutely need to. So you need to have certain amount of scale if you want to implement this type of architecture. Server-side rendering makes things a lot more complicated. So, like, if there wasn't a server-side rendering, it would be just a matter of loading a JavaScript file in a browser, which is it doesn't add complexity of running certain things on a server, certain things on the client. So this complicates things a lot. In our case, it proved to be very good decision to make everything framework or tool agnostic, so that we can iterate and adopt different tools as they come from the community. So we rely mostly on just like ECMAScript modules for loading something from a remote location. Then absolutely a must is to have a certain common vision around what are you actually aiming to build, and communicate this a lot. So very often communicate this to everybody so that everybody's aligned. You have to create a lot of documentation, conventions, guidelines, how to do certain things. Then also implementing additional tooling and frameworks that make developers do the right thing in a very easy way. Automating everything is absolutely needed, because now you don't have one big thing where like a platform engineer can come in and change things manually. Like, any change that you need to do now needs to be done across a lot of small different repositories. So you need to automate stuff. So things like, for example, we adopted Renovate to keep all the package versions in sync. This is super important. Automating the deployment processes, or how you configure CDN, for example. In our case, Akamai, when you want to deploy stuff, this is super important as well. So automation is crucial here. And of course, like, we know that we as a team are not going to be, we can't just in advance know everything. So we know that along the way we will learn a lot of things, we will change some decisions, and it's important to always try to improve processes and the ways how you do things. So for us, for example, key things are how do you get like a high level overview of all the things that you're running that make up a website right now. So instead of like going to one repository, now you have a lot of repositories. How do you make sure that all these repositories and teams are implementing a certain level of quality, are actually following your guidelines and stuff like that? So this is a burning topic for us right now. What should be shared code, what shouldn't, and stuff like that. This is something that you need certain level of governance across the whole development. And that's it. That's all I had. And thank you again for inviting me.
Awesome. So a couple of questions came up during the talk. Let's go over them. The first one was from Shamela. She asked or was wondering, better to say, header, footer, language selectors, and so on. That was on the slide where you had the applications and then the micro frontends below. Seem more like a component, not a micro frontend. So how do you define a micro frontend? We've also seen now in the code that you've shown, you always had an export default. It always looked like a micro frontend is just exporting a single component, but maybe that is just, you know, from this example that you've chosen there. So how do you cut it, and what's the relation between components, micro frontends, and how they then embed it?
Yeah, so I mean, we have pretty good guidelines around what should be a micro frontend, what should be a component, right? So if you're building something which has a lot of, let's say, logic inside, like you are connecting to different APIs, you also, like, the very important is that the ownership is very clearly defined. So once you, as a team, you own a piece of website and you want to update that across the whole website automatically, you need a micro frontend, right? So you can't just build an npm package. So if you need consistency across the website, you need to, let's say, roll out changes very frequently, and there is a lot of let's say, business logic inside of that part of the website. That's usually a micro frontend, right? So if you're building something which is considered to be like a presentational component or very static thing, that's the package, right? So for example, like a market selector, right? So how often do you change markets for a website? Well, maybe once or twice a year, right? So that's something which is pretty static. And what kind of logic does it have? Well, it doesn't have any logic inside. It just shows, for example, a drop down where you can pick a country, and this is just for example, static configuration inside. So it doesn't need to talk to any APIs or anything like that. It maybe just changes a cookie or something like that, or changes the URL. So that thing is something that is simple to package as a component. But the header, for us, if you go to the website, you can see that the header itself is a very complex component. So it has navigation inside, which comes from the CMS. It has search functionality, which talks to certain APIs to search products. So it has a login and registration inside. It shows the number of items in your cart, etc. So it talks to many different things, and many things are connected to the header. So that thing is something which is definitely a good candidate to be a micro frontend. And we have
yeah, but it's still a single component, and I think the question goes in a direction. I mean, usually a micro frontend can consist of multiple components, right? And here it seems that a micro frontend is always a single component. Now, of course, now we're talking more about what kind of component is it. It's just a display component, it's a domain component, etc. But it's just a single component at the end of the day, right?
Well, I mean,
or can it be more components?
Yeah, I mean, it really depends what you want to accomplish, right? So, I mean, in the end, like a whole application in React is essentially a root component, right? So what do you show and how do you show things are...
I mean, the thing is, it might be scattered out, right? So because if you do micro frontends, like we always propagate, you get consistent packages. Now, for instance, you bring in something that comes with a page, and that might be now what you say is my single component, but maybe you want to show that also in the header. Now, that shouldn't be now in the header micro frontend because that breaks consistency. If you, for instance, don't ship now the one micro frontend that comes with the page, now you still ship the header, you have a link that's invalid, right? And the link where it should go should be also governed by this other thing. So that already addresses that there should be multiple things now in this one micro frontend, because to stay consistent, it needs a fragment that lands in the header micro frontend in this case, and it needs to have this content piece That's might be now the bulk of the work, right? But it's different components that might be in there, right? And so micro frontend can consist definitely of different components that are different because they might be placed in different parts of the screen, right? But
yeah, absolutely. Okay. And also, like, if you want to, from a deployment side, if you want to have multiple micro frontends deployed at once, you can definitely do that. If you want to package them separately and you want to deploy them completely separately, then you would separate them, right? So it depends on the developer how they are delivering stuff to production. But definitely you can have many things in one micro frontend.
Okay. Cool. Then next one from Tanya. She finds the whole project very impressive, and she asks how long the implementation of the Soul framework took you, approximately personal man.
Yeah. So it took it took a lot of effort. So I can't give you a complete estimate, but let's say that when we started. We started, like, let's say 6 months in. After 6 months, we had a first micro front end in production, right? So we had this. Soul as well. I just shown here like that it has a functionality to bootstrap a micro front end, but since we are separating things, we are, as we said, we are building applications. So it also has ability to deploy, to bootstrap a new Next.js application, for example. It also has a functionality to deploy, to build a library, for example, like a package. Or it also has a support for building APIs as well, right? So we didn't build everything at once. We just focused on microphones first, and adding more functionality. So, but let's say 6 months in, after around 6 months, we were able to deploy a first micro frontend with Soul. Even before that, we started building libraries, which is this like micro frontend client to be able to load the micro frontend and expose a micro frontend, right? But Soul, that was even before Soul. Then we said, okay, we have a working prototype. We know how things work. So now we have to automate stuff. So now we can build like consistent tooling around it, how to build, how to bundle a micro frontend, where to deploy it and stuff like that. So it wasn't like, okay, we start now and then build for 6 months and then after 6 months we are ready. No, we were gradually getting there, and we started building a framework, and then at the same time working with the product team to release the first header as a micro frontend. But it took us 6 months to actually have first working micro frontend we saw in production, and I would say three people mostly worked on that for about 6 months.
And right now the core team size is still about 3 to 5, because you listed how many are working, of course, in total, but taking care of Soul, I guess everyone contributes in some sense, but what's the core?
Yeah. The core team is 5 people, so it is sizable. If you can afford 5 people working on infrastructure, you need to have scale for that. Yeah. So, but it's still, considering that we are supporting 100 people, it's not a lot.
Yeah. Before we come to the next question, one question from my side here: how is the debugging looking like? Because you mentioned, of course, fast start. But does it then start the micro frontend in isolation, essentially, that it just runs this part that you develop, or can you start it already in, let's say, how it looks on the website? Do you need to push for that, or how does that story look like?
Yeah. So what we do is when you're creating a micro frontend, we create a preview page for you. So you get a React page, which basically renders your micro frontend as the real application would. And you have the ability to put anything on that page that you want. So people usually put some testing buttons there, so that they intercept certain things that the host application might send to the micro frontend, and they see how it's behaving, right? So it's like a playground for people. And so there you can run any kind of testing. You can run integration testing, you can run end-to-end testings, you can connect to real APIs, do whatever you want. So that's the first thing. Then the second thing as well, since we have, let's say, remote configuration as well, we can enable and feature flags as well. We can deploy if we need. We can deploy a version of a micro frontend and test it only for us, right? So we can just make it so that it loads something from staging environment or development environment and see it how it works in production. So this is also possible.
Right. All right, and then of course another remark from Mutadi, who of course confirms that hydration adds an extra layer of complexity. The big question there is, of course, when you hydrate, and you were mentioning that you, of course, framework agnostic, so you might come into scenarios, you have hydration now of, I don't know, a micro frontend with React 17, one with React 18, but you need also then be capable of hydrating, for instance, Angular or something else, right? And is this adapter then very generic, or I mean, is it defined by the micro frontend how the let's say hydration should happen? And could I just write, for instance, a micro frontend using, I don't know, Quick, for instance, if I define how that works there? How would it go?
Yeah. So I don't know if I can show the slide, but
sure.
Yeah, go back here. Yeah, here. So here on the right side, index.js, right? So this is the JavaScript interface that the client knows about, right? So when I say something is a micro frontend, well, basically you have to implement these three functions: mount, unmount, and update. If you work with single spa, it's very similar to that, right?
Yes.
So this is a generic interface. How you update, how you implement this, it's up to you, right? So we have implementation for React, and if you want to use Vue or some other framework, you have to implement these three functions, and then the micro frontend client can actually load your thing, right? So that's basically it.
Okay, great. All right, then we got one more question here. Amine, he wants to ask, I mean, why React essentially? I think it's a little bit cut off. So did you try other things as well before? I mean, I think the decision for React was already historic, right? Because it was already monolith and potentially didn't want to, just for the sake of rewriting it, rewrite everything. You had every developer already being a React developer, but I don't know the story, so.
Exactly. So, I mean, key thing is here that when we started, we had a React monolith, right? So you had developers that know React. You don't expect to just switch a framework to use something else. Of course, as I said, we can actually use some other framework, but of course, it's not going to be Angular, right? So that wouldn't make any sense. So we would have to assess what framework would make sense for us. Of course, you have to keep in mind as well, like since this is an enterprise company, like it's not just you cannot just randomly pick a framework, right? So.
Yes.
Of course, we have a design library as well, right? Which is implemented in React. So if you wanted to use something else, you would have to figure out the styling part as well and stuff like that. So it really has to be like a huge benefit to us to use something else in order to start using something else. So we have support for that. And important part with this architecture as well is that we can start playing around with different things. So if we wanted to adopt a different framework, we could just pick a part of the website and start implementing stuff in that new framework if we wanted.
Okay. Maybe last part before we come to Matteo, because we now see also the thing that was cut off. Amine also wonders what you did about a global state. Is there maybe is it handled by Soul, or how are you handling global state?
Yeah, so we have so we wanted to have let's say decentralized way of defining state. What does it mean? It means that there isn't a thing which says, okay, application global state, full stop, right? And then you put random stuff inside. No, there are, let's say, a bunch of different domain-specific singleton instances which are running in the page. For example, how do you get a user? There is a hook to get a user, and it's basically the user information is a singleton thing on the website that exists, which you can fetch anytime, right? So that's a piece of global state, which you can, you have a simple hook to use that. On the other hand, there is a way to update the state as well. So there is a way to define global state, but there isn't a such thing as one global state. There are just a collection of singleton objects on the page, which you can interact with a specific interface. Like usually it's with hooks.
Okay. All right. Cool. Then we will discuss the rest later in the general discussion, and then we make the stage for Matteo.
Yes.
Nice presentation. The stage is yours.
Thank you so much, Florian.
Yes.
So, hi everyone. I'm Matteo. As I said, I'm 29. I come from Italy, and I'm a senior software developer at Nearform. And also, I'm a Module Federation contributor. The plugins that we are going to see today are the results of a working group that we did on Nearform in between November and January of this year, and of course the past year. And the necessity that we had initially was to fix some developer experience problems that we had in the project that I'm currently working on. So before starting digging in Module Federation, I would like to tell you my journey across the Micro Frontend. In my career, I had the opportunity to work in different scenarios in which Micro Frontend have been applied successfully. The first one is the first one was for an Italian company, well, an Italian bank, which called the Micro Frontend widgets. So multiple widgets were loaded in order to display the home banking of this company. Then, when I switched job, I landed in a company which were creating orchestrator for client-side rendered Micro Frontend. And when I left them, I also decided to create my own orchestrator for single for client-side rendered Micro Frontend. You can see the link of that project in the lower part of the deck. But today we are not here to talk about Orky, but we are here to talk about Module Federation, which is the latest step that I've made in the Micro Frontend world. So what is Micro Frontend? There are multiple definitions on the web. Michael Gears defined them as a way to extend the microservices concept to the front-end world, while for Ken Jackson is an architectural style that allows us to deliver application that can be composed into a greater whole, while Luca Mezzalira defined them as a technical representation of the business of your business subdomain that you're going to implement and deploy them in an independent way, while for me are just an architectural approach that allows you to have freedom and independence to each of your team. So how can we split our page when we are going to approach to micro frontends? There are two general rules. The first one is to apply a vertical split where you have a single micro frontend for each of your pages. And we also have the horizontal split, where in a single page, you have multiple micro frontend which are rendered together inside your page. And how do you compose them? Even in this case, we have different techniques. The first one is client-side composition, where everything is composed inside our client, for example, our browser. Another technique is to use the edge-side composition, where, for example, on the CDN, you can use a specific language called edge-side inclusion, which allows you to compose your micro frontend and directly return the composed view to your client. This technique is a bit hard because each edge implementation has its own edge-side inclusion languages that can also behave in different way. And another technique is to use server-side composition, where you compose everything inside your server and you deliver the result to your customer, to your client. The concept that I explained to you in these two slides can be also found in a beautiful Medium article made by Luca Mazzalira called Micro Frontend Decision Framework. Now, for the example that we're going to see today, I opted for a horizontal split and a client-side composition. Horizontal split just because I wanted to take the easiest approach, and the client-side composition just because it's just an example. We don't need server-side rendering and stuff like that. So let's take a look at module federation basic concept. What is module federation? It's it has been made from a single person, which is actually the main maintainer called Zachary Jackson, and it is a technique that allows us to distribute software at runtime with additional support for fallbacks and shared libraries. For shared libraries, I mean versions of React, for example. And it works for both client and server. Today, we are going to see only the client part. A module that you can use with module federation can be a remote, where and a remote is simply defined as a module where you expose your components. A bidirectional host is a module that imports some components and export other components, the same or different one, maybe enriched, while the host is a module which simply imports and consumes the component that we defined with a remote or a bidirectional host. This is essentially the example that we are going to see today. So on the left side, we have a React component called button, and on the right side, we have another component, as I have as my fantasy is huge. There is another component, another button, but the difference between the two is simply the label. on the lower part of the deck, you can see the configuration that you have to apply in order to expose them as a federated module. The first entry that we need is the name. So this name will be used on the host where we are going to import this remote. And then we define the exposes object. On the left side, so as the key of our object, we have the path in which our component will be loaded by the host. While on the right side, so as a value, we have the path in which our component is defined in our actual project. After that, we simply define the shared libraries. In this case, we are telling to Module Federation to share both React and React DOM as singleton and to consume them in an eager way. The version that is actually required, I'm taking it from the package JSON. It is a great technique in order to have a single version of React inside your page and to also avoid some unexpected behaviors. There are some techniques to mitigate it, but if you have the possibility to avoid having multiple versions of the same library inside your page, it's always the best. So now we see how we are going to import this our federated module. As you can see here, we have our module federation TypeScript as name as we had in the remote, and we simply import them and use as any other component. Exactly. The most important part that we have to take a look here is the remote part, because I mean the shared configuration for the libraries and the dependencies are always the same, but what we want to take care is the remote. So this part here is the same that we have defined in the name of the remote component. While, let me change color. Here we have the host that we are going to contact in order to download our bundle for our federated module. While here, oops, let me highlight it better. While here, we simply define the name of the module that we're going to use inside our host. For simplicity, I've used the same for both the name of remote module and the name of the module that we're going to use here. But as general rule, just know that this module refers to what you are going to have here, and of course, here as well. So now, Florian, I would like to just make a question to you as well. Do you think that the configuration that I showed you till here is enough in order to run our federated host and remote? I can go back if you want.
Depends, but I would say, I mean, if you ask like that, the answer is potentially no, but I haven't seen something that is missing, to be honest.
Mm-hmm.
I mean, it's only part of the Webpack config, right? You can't run it like that. It's just the part that defines the plugin of module federation.
Exactly. Okay. Yeah. I mean, I've hidden the module federation configuration, but okay. I wanted just to ask. I mean, with this configuration of module federation and this configuration of the components. So in this case, the answer is yes. We are able to run our federated module. So as you can see here from this screenshot that I took from Firefox, we have our buttons. Their label are actually different. So yes, we are good to go. So after all of this, there's still a question that we have to answer. At the beginning of the presentation, I told you that we face some problem, some developer experience problem related to module federation. So what are these problems? I mean, we are able to ship JavaScript at runtime. We are able to use both the host and the remote. So what could be the problem that can affect our developer experience? Florian, do you want to guess?
There are many with the module federation out of the box. But if you want to start with, you don't get no typing at all, right? So you don't even know that this package exists. You don't even know what it exports. And I mean, arguably, you also can't know because you can't control the URL for eternity, what is there. So since it's just bound at runtime, it can be anything, right? So in that sense, it's quite honest, but it's of course very unfortunate because at development time, you know exactly what you're working against, right?
Exactly. In fact, the first problem is related to TypeScript. And why it is related to TypeScript? Because, as Florian said, we are trying to import some modules which are actually unknown if we want to use our federated module. So what are the solutions that we can apply in order to fix this problem? This is, by the way, a real
Create a
screenshot.
DTS, define the module there, and put all the DTS from wherever the real code lies. Just
Exactly.
copy paste.
Man, you read my mind. So
Yeah,
exactly, the first solution is to define the interfaces for your properties or define your modules by yourself. But when you reach a situation like Alex was explaining before, where you have 80 different micro frontends, it's becoming really a mess because it's really, really hard to maintain and scale software that you have to align by yourself. So that's why I came up with a solution that is actually available inside the Module Federation official repositories, which is called Native Federation TypeScript. This is a plugin which actually allows you to create and share the types for you across your micro frontends. So, for example, we have defined our buttons, and as you can see here, the plugin is able to recreate all the definitions file for you, just simply with booting up your micro frontends. So how does it work in the background? We have our two actors, so the remotes and the host. So when I start up my remote, it starts bundling the micro frontend. It starts building the TypeScript types. It creates a zip folder in which these types are actually stored, and uses one of the functionality of your bundler in order to serve this zip file over the network. So the host, once it's up and the bundler starts as well, it simply say, okay, I know that at localhost 3000, I have this federated module. Let's go there and ask for the zip folder which contains our types. It receives back, unzip its content, and as we see here, extract them in the @mf hyphen types folder. So of course you have to configure the TypeScript compiler path in order to load these definitions, but at least we don't have to manually write all of them. Additionally, to all of this, I've also found another problem with the developer experience. And Floyer, do you feel lucky enough to guess the other problem?
So, I mean, I could point out some problems. One that I have is with the wiring of the URLs, but I'm not sure that you tackled this one there. So,
Mm-hmm.
no, not
Nope.
sure.
Unfortunately, I will not talk about this, but I will talk about the test, which of course is an essential part of our developer journey. So the problem that we were facing with the test was something like this. This screenshot is from Virus. It's quite old version, but because I prepared this presentation some time ago. But when Virus, or Jest as well, tries to load our module, they say, okay. I mean, the main part of the error is over here. So, okay, you are telling me to load this module federation TypeScript / another button, but I don't find them in the node modules. I don't find them nowhere. So how can we solve this kind of problem?
I mean, I personally would mock it away because, again, you could now implement a loader and everything, but then, again, this is a part of the application that will be combined at runtime. So you might not in your unit test want to care about it, right?
Exactly. The first solution is, of course, to define your own mocks. So using jest.mock, vi.mock, if you're using Virus, you are going to define the name of the module, the factory, and you are free to go. For Jest, you also need to define a third parameter, which I don't remember the name, because since this module is not in the node modules, you have to define this like blank module just to say, okay, you don't find it, don't even try to search it through node modules, just trust me, it's there. For Virus, this is not needed, but it's a configuration needed only for Jest. But what is the problem when we create manual mocks of our component? The first one, of course, it's hard to scale because, again, if you have 80 different repositories, it's hard to maintain 80 different copy of the same mock. But it depends a lot on how you mock it. So in our example, we were just returning a plain button element. But in this case, if we take, for example, a snapshot of our output, the result is far from being the same that we expect at runtime or doing our normal execution. And that's why I created another plugin called Native Federation Test. And this time, what we're going to do is simply we concatenate the source code of your component, and an example is directly here. We completely exclude your dependencies, and we simply ship it to the host. So it is able to directly have an automatically updated version of your box. So the mocks are actually stored in the __mocks__ folder. In this case, the folder is different than the one that we have for the types, just because this folder is the standard one used by at least Jest and Virus if you have the automock option enabled. Once again, how do we do that? The same way we did before. So the remote starts, the bundler starts, it builds these source files using a different configuration than your standard bundle, just because here we are using a different bundle just to concatenate your source file into a single file. We create a zip file with all these files, and we serve it using the bundler API. Once the host is booted, it starts start building your federated modules. It asks for this test zip folder, and it extracts them in the __mocks__ folder that we see before. And in this way, we are able to solve also this problem with the snapshot, because the component that we're going to render during our unit test will have the same behavior that we have at frontend, so which is actually this and not this, simply plain buttons that we don't want them. All right, and why I call this both this plugin native hyphen federation hyphen something, just because both of them have been made using Unplugin. Unplugin is a unified plugin system for build tools, and it allowed us to have this plugin for all the measure bundlers that are available online. So ES Build, Rollup, the newest RSpec, Vite, and of course Webpack. Module Federation initially had TypeScript plugin, but it supported only Webpack. While with this plugin, we are going to support a vast majority of the Module Federation ecosystem. Yeah, on my side, that's it. And I would like to ask to everyone is watching us if they are so kind to provide me some feedbacks about this presentation. You can just write me on LinkedIn, directly contact me on Telegram. And yeah, that's all for me. And thank you so much for having me today.
Awesome. That's really cool. Thanks for sharing. So far, I haven't seen any question to this talk in the chat. There have been a couple more questions regarding Alex's, but we can come to them in a second. Maybe I start then with some questions. So that was cool. Now regarding the testing part, you still need to wire up the mocks, right? Because I mean, they will be placed in the mocks directory, and you would still need to refer to them. So you opt in still, right? So you use, of course, the plugin, or I mean, the two sides would use the plugin, right? So the one side is the producer of the module federated or module federation bundle needs to use it because they need to zip it up, right? Mm-hmm. And then on the consuming side, you also need to use the plugin, right? That it knows.
Exactly. There are two different versions. I mean, The plugin is one, but inside one package, we're actually distributing two different plugins, one for the host and one for the remote, because the remote part just needs to, the remote part just needs to actually apply the business logic just to build the definitions files and the mocks, while the host just needs to download them. So we provide in the same package two different plugins, which does two separate jobs.
Sure.
For bidirectional hosts, since they both import and export component, they need to actually use both of them.
Yeah. But the question is then now, I mean, again, you consume one, so it gets unpacked, it lands, as we've seen in the mocks directory, but you then still need to, I mean, let's say use jest, you need to still opt in, right? And say, I want now to mock this thing.
Well, no, because the __ mocks _ folders in jest,
if
it automatically picks up
you can configure something else.
Exactly. The story is a bit different in Vitest because Vitest does not behave in the same way. So you still have to use the vi.mock function, but in that case, you only have to define the name of the module, not the factory for the implementation.
Okay. And you can, I think, also in jest opt out, right? So let's say you configure it to the __ mocks, and it would be automatically picked up, but you could also then opt out for certain tests, right? And override it, right? So you say because I mean, in general, you might not want because then you depend now on something. I mean, you've seen the snapshot. I mean, actually, I would argue if you put in your snapshot this thing that comes from the remote and can be updated anytime, I mean, your pipeline might break anytime. So you might want to control that, right? And
exactly.
Not opt in if you make a snapshot, for instance. Say, I just want to make sure that this microphone is rendered at that location, not what is exactly rendered there, because that's the job of this microphone, but I want to control what's then in the snapshot that, it just doesn't change between two runs.
If I remember correctly, because it's tester dependent API, you should be able to define a new factory, and then it should discard the _ mocks folder. Yeah.
Okay. All right. Then we got, I think, a question from Tanya. She refers to native federation is pretty cool, but currently not yet available for all build systems. There is no Webpack adapter yet, for instance. I think she refers to the thing that Manfred came out with, a native federation, which uses the same mental model, but is incompatible with module federation as in Webpack module federation, right? And so the plugins we've seen, they are working for module federation.
Exactly. The plugins we have seen here works for module federation, but module federation as an organization provides also plugins for other build systems. Yeah. So there is a plugin, for example, for Vite. If I remember correctly, it is made by George Oboa, yes, which is following us today, and he is actually maintaining it. So yeah, more will come in the near future for RSPack, and there are also some plugins for Rollup for module federation with the same configuration but applied to other bundles. Of course, the main focus has been Webpack for now, but I think that it will not be in the near future.
All right, cool. Now, since we have a couple of minutes left, and we got some questions, as I said, to Alex's talk, so maybe let's pick up that. The first, I think we don't need, it was pretty much already asked by Amime, but maybe you can still go into all the singletons that you described, how you can maintain a global state. Just briefly again from Mutadi.
Yeah. So as I mentioned before, there isn't like a single object that holds all the global state in the application. It is basically separate per domain. So we have a product domain that maintains the state of the card, for example. We have product domain that maintains the state of the logged in user and stuff like that. So it's a bunch of different libraries which the application and the micro frontend depend on, and this is actually maintaining the global state.
Okay. Then another question that also came to my mind, I think you touched it briefly when you were talking about ES modules, but what about sharing dependencies? So let's pick up the scenario that I had before, and again, React 17, React 18, okay, we need maybe to load 2 versions of React to do the hydration, but what if we have this scenario, and Matteo touched it also briefly, React 17, you don't want to load it twice for obvious reasons. What is your strategy there? How do you handle that?
Yeah, we depend on, we have a CDN for deploying shared dependencies, and everybody loads dependencies that they need from like a shared CDN space. So there is like React DOM, other libraries that we depend on. They are shared. Also, like we kind of are careful about sharing dependencies. So sometimes you don't necessarily want to share all the dependencies, and you want to them, but some of them we bundle, some of them we share, externalize, let's say. But we have a CDN where we place all the dependencies, and then they are loaded by the micro frontend and the application.
Okay. And if you want to bring in a new one, maybe that is a follow-up question. So let's say React 19 is coming out. Yeah. I want to use React 19, and I'm sure other teams will also go there. How can that's why I don't want to bundle it. How can I move it to the CDN?
So previously we had a let's say a system where you had a repo, you had a list of things that you want to bundle, that you want to have shared, blah blah blah. We are changing the approach. So we have internal system which is very similar to ESMSH, if you know what it is. Essentially, it's let's say let's call it bundlers as a service, something like that, where you can require any dependence, any package, any module from any package from our internal Artifactory to be exposed as a ESM module. So you build a package that's called my button 123, and I can just import it from a remote.
Yeah, that's quite cool. I think everyone can host like ESM/SH. The code from there is also on GitHub. But you can also use just ESM/SH. That reminds me, I just once looked up because I gave them a package where you would need a custom loader to actually build it, because they have a good configuration, but it can't handle anything. And you can even specify in the query parameter certain things and that it gets in. But unfortunately, it can't be extended in that way, that you can actually teach it about special kind of loaders that you would need for some package that it can bundle it. But otherwise, it's really cool stuff. And I think the tooling like that is really great. So that's a good one. And also, and last one, for the moment at least, from Mutadi, what about the routing? So, we now got all these micro frontends flying around, and we've seen that it's processed by the server, but the server must, of course, also first identify what's this page, right? Where it now then gets, I don't know, further information, what it should now fill out and where it gets through. So how is the routing implemented?
So as I said, we have this vertical split of things, which you have different, let's call them Next.js applications, which are running side by side. So the first thing is that we have CDN in front, which basically based on the route defines which application should serve the request. So that's the first routing part. After that, the application takes the request. It knows its own set of routes, so it knows with what it can actually do soft navigation with. So let's say you are on a home page and you have another page inside of this application. So between these two pages, you will have the soft navigation. And if you're navigating to something that you don't really know what it is, it will do a hard refresh, right? So then Akamai would decide if it has to be handled by some other page or it would be just a 404, for example. So so that's let's say very simply put. There is a lot of complexity on top of that. For example, a lot of our routes are completely dynamic, meaning that the page, you can create something like /my_super_campaign, which doesn't have a prefix. So you don't really know what it is, right? But we have certain APIs that tell us, okay, is this page coming from the CMS, or is this page like a page which should just render a list of products and stuff like that? So the routing is a bit complex, but essentially routing starts from Akamai, and then the application itself knows a set of routes that it can handle.
All right, cool. Since we approach the end of time, maybe we make one last round, and as a trigger point, I use the comment from iMark90, who refers to RSpec as the potential future there for module federation, as Zachary Jackson is now also working there. And RSpec is, of course, one of the new generation bundlers that has a native implementation under the hood and really claims performance-wise to be the new kid on the block. And that's why I want to trigger the round. So what are the things in web development space or in tooling also regarding that space that you look forward to or that you are most excited about? So maybe let's start with you, Alex, and then let's conclude this with Matteo.
For me, I'm very excited about the standards, the web standards like ESM, import maps, these type of things, which are, let's say, tool or framework independent. So this is something which, like if you just think about ESM, for example, and how much complexity they actually abstract for the bundler to do. Like you don't have to think about like which format of the. So you kind of like you offload a lot of runtime stuff which the bundler did for you to the browser, which I think is amazing. So this is like how you went from jQuery to some native API. Same thing is now happening with how you handle modules. So this is something that I'm super interested about. I mean, RSpec, for example, I had a pleasure meeting and talking to him about this. And I think, for example, while we are in the process of migrating to all the things that I explained today, so we have certain very big parts of the website that are running on Webpack, for example. So for me, we want to investigate if we can actually migrate this to RSpec. It should be, we try to do it on a very small scale, but for example, it could bring a lot of benefit for us as well.
For you, Matteo, what are you looking forward to? You're muted, Pretty.
Oh, sorry. I would say the same. I mean, to me, one of the all the latest web APIs, but above all of this, the biggest feature that I like is the import maps, because they allowed me to actually implement a piece of my Micro Frontends orchestrator, which I showed you at the beginning of my deck. So that is the biggest one. And about RSpec, I'm excited too, and let's see how it goes, because actually, yeah, it seems that maintaining something like Webpack is becoming harder and harder, and we see it with module federation, for example, where the standard plugin are harder to evolve because as they are actually part of the Webpack code, are hard to evolve. So yeah, let's see how it evolves. But I am literally excited for that.
Cool.
For that and for what was like 2 weeks ago, Rome.
Okay.
Which now
Rome has fallen.
Has fallen. Now we have another tool which I don't remember the name.
It's called Biome, I think, or something like that.
Yeah.
Cool. All right. So that's it for today. Thanks for joining, and wish you all pleasant evening. To all our viewers, great weekend already, and see you then next month.
Yeah. Thank you so much.
Thanks a lot.
Bye.
Thanks. Bye.